You can see the screen.
Yes, sir.
Okay. So I just want to summarize what we did last time. Okay. So this is a Rainman problem. So here the man is walking with a velocity Vm, and the rain is falling vertically down. So this is with respect to ground or with respect to the man?
With respect to ground.
Yeah. Okay. So with respect to the ground, this thing is falling vertically down. So another possibility is the rain is falling at an angle. Okay. With respect to the ground, there is one more possibility, right? It can fall this way. It all depends on the wind direction.
Yes, sir.
Okay. So this one, in this situation, what will be the direction of the umbrella?
If the man is walking in, he has to hold, but like tilted.
Yeah, just a minute. So if the man is walking here, so it will be in this direction, right? If the man is not walking, it will be vertically upwards. Okay. So the way to understand this is when he's walking, say, suppose he's here at the initial time. So at that time, there is a water drop here, raindrop. So when this person moves to this location, this drop would have reached here and hit the umbrella. Okay, it's as if the drop which was in front of him has come and hit him. So it's as if the velocity of raindrop is in this direction. So it's the umbrella will be in that exactly same direction. Is that clear?
Yes, sir.
Okay, and this is a basic relation of a relative motion. Velocity of rain with respect to man is velocity of rain minus velocity of man. Okay, so this is the only possibility here. The umbrella can go only in the forward direction. Should be tilted in the forward direction. So here in this case, what will be the direction of the umbrella? Forward or backward or vertical?
Vertical.
Vertical means vertical means the drop which was here initially. After he walks the distance, that same drop should hit him. Is that possible? See, if the umbrella is supposed to held vertical, see here is the initial time. At the initial time, there is a raindrop here. So after some time, the person would have moved here, right? So when the person has moved here, this drop should hit him. Is that possible?
No.
Okay. So you're then the so again the umbrella should be in this direction only. Okay. To understand that, for this to happen, take a raindrop on the front side. Okay. So by the time the raindrop reaches here, this person would have walked up to this distance. Okay. So it's as if this raindrop has traveled in this direction. So the umbrella will be in the same direction. Is that clear?
Mathematically, how can
Yeah. We will get to the mathematics later. Mathematics is only one relation. Okay. We'll come to that later. First, understand it physically. Okay.
okay.
So whenever the raindrop in the front hits him, okay, it will be tilted in the forward direction. Okay. Now consider this situation. So in this case, what will be the direction of umbrella? Forwards, vertical, backwards. It can be this way, right? Okay. So for that to happen, the water drop, say initial time is here, the water droplet which was here, okay, as it moves to this position, new position, so the drop should travel like this and hit him here. So it's as if the drop which was behind him has hit him. So it's as if the what rate the thing is traveling in this direction, so the umbrella should be in the opposite direction. Okay, so is it possible to hold the umbrella vertically up?
Vertically up.
See, here it's tilted backwards, no? And I gave an explanation why it can be tilted backwards. I took a water droplet here. It will travel in this direction. So by the time it comes to this level, the person will move to this much. So it's as if the water droplet which is behind him has come and hit him. So for that, he has to tilt the umbrella backwards. Okay. So in this situation, will there be a case in which the umbrella should be held vertically upwards? Okay, it's possible. See, take a droplet here. Okay, so this droplet will move like this. Okay, so by the time this person has moved this much, it's as if the drop has vertically above drop has come and hit him. So in that case, the umbrella should be vertically upwards. Okay.
To keep it vertically upward means then the
See, initially at this
will hit him anyway.
See, initially the person is here. When the person is here, he looks the droplet here, which is vertically above him. Okay, since the rain is in this direction, so this droplet will keep moving in this direction. Okay, so by the time it comes here, this person has moved this much. Okay, so this vertically above drop will come and hit him. So it's as if the rain is falling vertically downwards with respect to him. So the umbrella will be vertically upwards. This all depends on the value of the man, velocity of the man, and the velocity of the rain. Depending on that, the situation will change. Okay, it's also possible for the umbrella to be put in the forward direction. For that, what should happen is just a minute. For that, what should happen is when the person is here, there will be a droplet here, no? Okay, so that droplet will travel in this direction. Okay, by the time it comes to this level, this person should have traveled this much. So for the thing to be tilted in the forward direction, the velocity of the man should be higher. If the velocity of man is lesser than that, it will be vertically upwards. If the velocity of man is still less than that, the umbrella will be backwards. And if the velocity of man is 0, then also it will be backwards. So in this particular situation, it's possible for the umbrella to be either tilted backwards, vertical, or in the forward direction. It depends on the velocity of man compared to velocity of the rain. So if the velocity of man is more, then he'll travel larger distance. So it's possible for him to catch a drop which is in front of him at this position. Okay, so but that is not possible in these two situations, because here the velocity, for it to be tilted backwards, he has to take a droplet here and make it come and make it hit him. That's not possible because the rain is flowing in this direction. Okay, similarly vertically above droplet also, for it to hit him, this droplet will travel in this direction. So it's not possible for him to hit him. Okay. So mathematically it depends on this relative angles of VR and VM.
Diagram and line diagram.
So velocity of man is this one.
Okay.
And velocity of rain, see this one, right? So velocity of rain with respect to man is velocity of rain minus velocity of man. So it is this one. This is the relative velocity, and the direction of umbrella depends on this relative velocity. Okay, this will decide the direction of umbrella. Is that clear? Okay, so this direction, suppose if VR is small, okay, so it will be in this direction. So the umbrella will be this way. Suppose this VR is large, okay, then the relative velocity will be in this direction. Okay, then the umbrella will be in this direction.
Vertically downward one, minus VM.
All the signs include in the direction. Don't look at mathematics like that. Yeah, it's VR minus.
VR plus minus of VM, then it will be vertically downward only, no? VRM.
No, that depends on the magnitude of VR and VM. Okay, I'll draw it again. See, this is direction of VM, right? There is no confusion in that.
Yes, sir.
Okay.
Minus VM.
Hold on.
Okay.
This is direction of VR. There is no confusion in that.
No, sir.
Okay, so minus VM will be in this direction. Okay, so this is VR plus minus VM. So that will be in this direction. So this is VRM. This is resultant, right? So this is VR plus minus VM.
Okay.
That is VRM.
Yes, sir.
Okay, so for this VR to be vertically downwards, so this VR should be of that particular size. Okay, if VR is less than that, then the resultant will be in this direction. If VR is more than that, then the resultant will be, or the relative velocity will be in this direction. So in this case, the umbrella will be in the forward direction. In this case, the umbrella will be bent in the tilted in the backward direction. In this case, the umbrella will be in the vertical direction.
Okay, based on the magnitude, also the direction change.
It is only based on the magnitude, the direction will change. Because the third violet case, this man has to travel this much distance, no? So VM is larger compared to VR. So here instead of I'm adjusting VM, I adjusted VR. Both are same. Even if you keep VR fixed and adjust this VM value, the same result you will get.
But I have never thought this kind of extra addition.
You must speak loudly. You have to speak loudly. I cannot understand.
Okay.
See here in this case, VM and VR. VM is okay. I think you are right. I think I made a mistake here. VRM is velocity of rate with respect to, so it's VR minus VM. VR is this way. VM is this way. It's minus VM. Velocity of rain with respect to man, right? This is the one that will decide the direction. Okay. Okay. Just give me a minute. So suppose I take this particular direction of this rain. So here the rain is this way, right? VR. And my
Yes,
VM
sir.
is this way. So this is VM. This is VR. So minus VM is this way. So VR plus minus VM is this way. So this is the relative velocity VR. Okay, here, depending on the, if VR is more, then it's going this way. Okay, so here also I'm in three directions then. Here VR is on this side, it's on the front side. When it's vertically downwards. VR. Right. I think what you said was right. This is wrong, no? This is wrong. So this triangle is see, this triangle is wrong. This triangle is possible in this case where we are. See, this is actually VR plus VM. Okay, so here, so in this case, VR minus minus VM will be VM will be here, right? So minus VM will be here. So VR minus VM will be in this direction. So the tilt is in the forward direction only. Got it? Okay, in this particular case, this thing corresponds to this one. Okay, so here the tilt is always in the forward direction. Okay, here in this case, this is tilt is all three tilts are possible. You got it, no? You just tried it after the class. I made a mistake here. What you said was correct in the beginning. I made a mistake here. Okay, so this blue arrow is wrong. Okay, this purple arrow is correct. So depending on the size of this VRM, it independent, even if the size is small or big, it's always in the forward direction, the tilt. But in this case, the tilt can change directions, either forwards, vertically, upwards, or backwards. Okay. I figure out after the class. So this is the summary. If raindrop from the hits from the front hits and umbrella is tilted forward, raindrop at the back, then tilted backwards. Raindrop is vertically upwards. If it hits him, then the umbrella is held vertical. Okay. So these are the. So there is no further complication in this rainman problem. Okay. The velocity of man is fixed. There is no change in there. Only combination is this rain. With respect to ground, that can be vertically downwards or hitting him in this direction from the front, or it is coming from the back. Okay, when it coming from the back, it's possible to tilt it in three ways. There is no other complication of this problem. So here there is a question. The rain is falling in this direction at an angle 53 degrees, and this person is going up an inclined plane whose angle is 37 degrees. Okay, at some speed. So you have to find at what angle this umbrella here should be tilted so that to protect from the rain. So velocity of rain with respect to ground is this one. Okay, the speed has been given as 50. Okay, and this 53 angle. So cos 53 and sin 53 will give this one. Basic mathematics. 53 degrees will form a 3-4-5 triangle. Okay, and velocity of wind and wind. This is woman. W is woman. Woman is riding this bike or whatever cycle. So this thing, 100 kilometers is the value and 37 degrees. So again, 37 for 3-4-5 triangle. So cos 37 and sin 37. So 100 will become 180 plus 60 J cap. Okay, so velocity of rain with respect to wind is velocity of rain minus velocity of wind. Sorry, velocity of rain with respect to woman is velocity of rain minus velocity of woman. So these two are known. So from this we can find velocity of rain with respect to woman. So this direction is minus 10, minus 110 I cap. So this one. Another component is minus 100 J cap. Okay, so the velocity of the rain with respect to the woman, the resultant is this one. So the umbrella will be in the direction facing it. So this angle theta is tan inverse 10 by 11 or 11 by 10. This is also a complicated problem. The rain is falling in the forward direction, and this woman is riding in some direction, which is at an angle 37 with the horizontal. So everything, if you write vectorially, your mathematics is strong, right? So you should do this problem.
Yes, sir.
Okay. So in 12th standard, use school exams, mathematics was there for you?
Yes, sir.
Okay. Right. So, right. So see, even the reverse simmer problem. So here the velocity of the river is constant. In the sense, there is no competition there. It is flowing in one direction. Here the competition can come. This is the velocity of man, or you can call it swimmer, and also boat. Okay, it can be in three directions. Either this with respect to ground or with the bank. Okay, so there are three possibilities here. One, the swimmer can swim in this direction. Okay, or he can swim in the forward direction, or he can swim in the backward direction. Okay, so this is with respect to the ground. So, and another thing is whatever is the swimmer's capability, that will be with respect to the river. If the swimmer has the capability of swimming at a speed of 5 meters per second, the swimmer's capability is 5 meters per second. That means it's with respect to the river. Okay, this will be a constant because this is swimmer's capability. Okay, the magnitude, but the direction he can choose depending on what he wants to achieve. If he wants to swim across this bank in a shortest path, then he'll choose this vertical path. If he wants to swim in the shortest time, then he'll choose this direction. Okay. So those two problems you have sent the snaps. So I have actually put the thing in the comment itself. Did you read the reply to the comment?
Yes, sir, but I haven't get it yet.
Okay. Add by 10.5. See this one. Okay, so here, okay, this method you understood, right?
Yes, sir.
Okay, so in the second case, you just have to choose the reference frame attached to A because A is moving with uniform velocity. So I put the reference frame to A. So with respect to the frame, you write all equations of motion. So attach frame to A. So velocity of B, everything with respect to A. So it's VB minus VA, right? And initial velocity of B with respect to A is UB minus UA, that is minus 10 because initial velocity of B is 0 and initial velocity of A is 10.
Okay.
So UBA is minus 10 because positive direction is towards right. Okay, and it's VB minus VA and VA is positive or UA is positive, so it's minus 10. Okay, and this BA is initial displacement plus UT plus half AT square, and everything is with respect to A. This equation is clear. S equal to UT plus half AT square. Actually, this S equal to S naught plus UT plus half AT square. Usually S naught is 0 because displacement is 0 time t equal to 0. But here the relative displacement is not 0 time t equal to 0 because the relative displacement is 10. Okay, so the S equal to S naught plus UT plus half AT square. And this is relative this thing. So and it's everything is relative to A. This one is clear?
No, sir. No.
You know S equal to UT plus half AT square, no? Okay, so in that the full equation is S equal to S naught plus UT plus half AT square. That is clear?
Yes, sir.
Okay, because S naught is usually we assume it's 0. There is the assumption that S is 0 at t equal to 0. But if S is equal to S naught at t equal to 0, then the full equation is S equal to S naught plus UT plus half AT square. That is clear?
Yes, sir.
Okay, so the same equation you just have to write in the reference frame attached to A. So whenever you use that frame attached to A, you just have to add this suffix A. Instead of SB, you just have to write SBA. Instead of SB naught, you have to write SBA naught. Instead of UB, you have to write UBA. Instead of AB, you have to write ABA. Everything is referenced to the reference frame which is attached to A. So this is clear now.
Yes,
This is with respect to the frame attached to A. This is clear?
S of B minus S of A. That's
Speak clearly.
S of B minus S of A naught.
No, not
You
this.
have given it as 10.5, no, sir.
Yeah. See, SBA, this one, it's actually not. SBA not is SB. Okay, I made some mistakes, trivial mistakes.
Yes, sir.
Is this clear now?
Yes, sir.
Okay,
Yes,
so
sir.
initial displacement of B is 0 and initial displacement of A is plus 10.5. So 0 minus 10.5 is minus 10.5. Okay,
Yes, sir.
similarly AB is AB minus A and acceleration of B is 1 because it's 45 degrees and acceleration of A is 0 from the graph.
Yes, sir.
Okay, so now it is clear.
Yes, sir.
Okay, and this SBA, when the two things meet, will be 0
Yes, sir. Yes, sir.
because with respect to the framework. So this is exactly the same equation you can get here. So the equations are same, 10.5 plus 10t equal to half t square. That's exactly the same equation you get here also. 10.5 plus 10t will go on the other side equal to half t square. So the equation is same. Okay.
Yes, sir.
So there is that one. And another thing you asked is yeah, see the given VT curve, the slope is same, right? It's always positive.
Yes, sir.
Okay, so in the first case, when the stone is turned vertically upwards, the acceleration is downwards because of the earth. So here also acceleration is constant. Okay, here it is positive if you assume that the downward direction is positive. Okay, so you can choose downward direction also as positive, but here it's DP is definitely not correct because it's decelerating and accelerating. So the slope will change. This and this are different. Decelerating means the slope has to change sign, no? And accelerating, the slope will be opposite of decelerating. So option B is not true. And A is true if you assume that the downward direction is positive. Because here the slope is positive.
Positive.
Is it okay?
So that velocity graph alone will explain for you.
No, speak loudly.
That velocity graph for A alone will explain the considering downward direction as positive.
Yeah. Usually we assume the upward direction is positive, but that's arbitrary, no? It's not
That graph alone you just explain.
Yeah, here we are assuming that the downward direction is positive. That is the only difference. See, for the stone which is being thrown upwards, okay, if you choose the downward direction as positive, then the equation of motion is V equal to U plus GT, right?
But going upward in time of ascent, the velocity must reduce now. But in this graph, it is shown like it is increasing.
You are saying you're strong in maths and you're still asking this one. Okay.
No, I never said like that.
You have to write the equation and see. See, if this is Earth, okay, I'm throwing vertically upwards. I'm choosing the downward direction as positive. Okay, so you have to write V equal to U plus GT. Suppose U is some 10 meters per second. So here it will become minus 10 plus GT. Okay, so now as time increases, this thing is decreasing, right? So you have to write minus 10 because downward direction is positive. Okay.
Time increases Then velocity also increase only, sir.
No, it's minus, no.
But that is fixed only, no? Like constant.
Constant also, see, initially this thing is 0. After it will become 1. After it will become 2. It will become 3. Finally, it will become 10. Okay, so what is happening to this sum? Initially, it is minus 10 and then minus 9.
It is increasing, no?
See, you have to check the magnitude. It is, no, it is not. See, it is, you just look at the magnitude. You can take the direction later. It is decreasing in magnitude, right?
Magnitude decreases.
So that's what is making sense, no, physically. Speed is decreasing. Okay.
Okay.
Don't get too much into mathematics because that will give you have to look at certain stages, but rather you have to think physically.
Thank you.
Right. So, right. So this is clear now, right?
Okay.
So what should I do now? Just a minute. Should I do circular motion?
Yes, sir.
Okay. Just read this problem. A body in circular motion with constant angular velocity, the magnitude of the average acceleration over a half period of revolution is dot times the magnitude of the instantaneous acceleration. Okay, so average acceleration, instantaneous acceleration, we have to compare. Bodies in circular motion with constant angular velocity. So can you try this problem? So what is average acceleration?
V2 minus V1 by total time.
Yeah, it's delta V by delta T.
Yes, sir.
Okay, and instantaneous acceleration is dV by dt.
Yes, sir.
So what is the answer? Half revolution. Can you try?
So for half a revolution means how to make a instantaneous acceleration.
See, instantaneous acceleration will be constant, uniform. So any instant you can choose. Okay, when you say average, you have to mention 2 time instants. Instantaneous acceleration means it's if it is uniform, then you can choose any time instant and find the instantaneous acceleration.
Both radial and tangential acceleration.
Constant angular velocity. So there will be only radial. Okay, so if omega is changing with time, then tangential acceleration will be there. Here omega is constant, so only radial acceleration is there.
Okay. 2 by pi.
Option A. Yes. See, this is what is happening, right? Initial position here, final position, because half the revolution. So average acceleration is Vf minus Vf by T by 2. And here, initial velocity is this one. Final velocity is this one. So if you take this one as positive, then will be, or I'm choosing this one as positive, this direction. Okay, so it's V minus V by T by 2. So this one. And instantaneous acceleration is V squared by, it's uniform circular motion for uniform circular motion is v square by r, which is omega square r. So this is how you did, right?
Yes, sir.
Okay. So just remember.
I didn't use that velocity concept, sir. Like average acceleration is equal to 2v squared by pi. Yeah. Yesterday we did not, sir.
Okay. Right. I usually derive things quickly. I don't like to remember too many formulas. I just remember the basic formulas, and from that I'll get the answer. So basic formula is delta V by delta t for average acceleration. For instantaneous accelerations, d by dt, and since it's uniform circular motion, our ultimate v square by r. Okay, this you have to know. Otherwise, it will be difficult to calculate. This is a big derivation.
Yes, sir.
This thing you have to remember. These things and all you don't have to remember. You just have to use a basic formula. Okay, this one. Here is non-uniform. This is also a simple question. Alpha, by definition, we'll get it. What is alpha?
4.
No. Alpha is angular acceleration, no? How is it related to omega? How is
d
acceleration?
omega by
Yeah,
d
alpha is
omega by d.
d omega by dt, and omega expression is given. So differentiate it with respect to time.
Okay, dt. Okay.
Yeah, alpha is d omega by dt. Got the answer?
No, sir. Let us omega is d theta
See,
by
when
dt.
you do d omega by dt, it becomes 2 theta d theta by dt, right? And then 2 plus 2. And d theta by dt is same as omega. And omega at theta equal to 1 is 1 plus 2, 3. And d theta by, and theta is also 1. So everything is known. Differentiate this thing with respect to theta. So it will become 2 theta d theta by dt plus 2. And d theta by dt is same as omega. So omega at theta equal to 1 you can find from this one. So use all those values, you'll get the answer.
Twelve, sir.
Which one?
12.
C. You got it?
Yes, sir. 12.
Yeah. So omega is different. So this is how we did, right? And d theta by dt is same
Yes,
as omega. So omega at 1, everything you need at theta equal to 1. So put theta equal to 1, you get the value of omega also. So this is done, right?
yes, sir.
Okay. This one. You understood the question, right?
No, sir.
See, this is a light here, okay, and this light is, it's sort of a torch light, okay. It will, or you can say laser light. It will shine in the direction it's pointed. So initially it's shining in this direction, okay, and this thing is getting rotated. So as it is getting rotated, this spot of light will move, right?
Yes, sir.
Okay, and this will move at a particular speed.
But
So you have to find how this uh, spot of light is moving, the speed with which the spot of light is moving. It will be a variable velocity. So now I have to find the velocity at theta equal to 45 degrees. So you just have to write the expression for xp. Let the coordinate of this point be xp. P is a point which is moving. Okay. And this angle is beta, say. So I can write tan beta as xp divided by 3. Okay. And actually xp is beta is changing. No? Yeah, tan beta is xp divided by p. So now differentiate both the sides. Beta is function of time. So derivative of tan beta is secant square beta d beta by dt equal to dx p by dt. Okay, and d beta by dt is known. D beta by dt is how much? 0.1 radian per second. Okay, from that we can find dxp by dt. You understood what I said?
yes, sir.
Okay, just just write tan beta equal to xp by 3 and then differentiate both the sides with respect to time.
Beta value, sir, 42 degrees.
Yeah. Theta is also a variable value. As time changes, beta will change, theta will also change. So at a particular instant, when theta is 45, you have to get the dxp by dt.
Secant 45 is one only, no, sir.
Secant 45. No, secant 40 is 1 by cos 45. So it's root 2.
Okay.
Root 2, cos 45 is 1 by root 2. And sin 45 is also 1 by root 2. So secant should be root 2.
Find 6, sir.
Option A.
Yes, sir.
Yes. Tan beta is xp by 3. So differentiate both the sides with respect to theta. You have to realize that beta is changing with time, xp is also changing with time. Xp is the coordinate of this point from this origin. So this one. So option A. Got it now?
Yes, sir.
Okay. So here there is one particular section on circular motion. Okay. 2000. Okay, let's start with one simple problem. Try the first one. Your mass is performing particular circular motion. It should be simple. Okay, this is a trivial question. It's a theoretical question. You don't have to calculate anything. Concept question. What is the answer? So the string will break under what condition? So the string will break when the tension exceeds a certain limit, right?
Yes, sir.
So at what position the tension in the string is maximum? When it is top, towards right, towards,
At A, point A.
no. See, the thing that's going to vary is the centrifugal force, right? mv square by r. See, if you take the string, okay, when the string is in this position, mv square by r will be in this direction, and anywhere mv square by r will be in the radial outward direction. Okay, there is no other force. Tension will balance is mv square by r, and velocity is maximum in which position? A, B, C, or D? mv square by r, which is the length of the string. This will be the tension force. There is no other force. So sorry, mg is there. Right. mg is also there. And mg is a component depending on the position. Okay, mv square. And so tension depends on the velocity. Okay, and also the direction of mg. So both will be worse at point B, because velocity is maximum at point B. So this centrifugal force is maximum at point B, and also the weight that will also be in the downward direction, opposing the tension. In here, the weight will be downwards, and mv square by r will be outwards, and the velocity is also less. So maximum tension is at point B, minimum tension is at point A. Okay, so this possible string breaking is more at point B.
So why at point B velocity will be more, sir?
That is the concept of vertical circular motion, right? You can consider in terms of potential energy also. Suppose you assume the Earth is somewhere here. So here the potential energy is high, right? Here there is drop in potential energy. So that drop in potential energy goes in increasing the kinetic energy.
Okay, okay.
Even when you drop a ball from a height, as it goes down, the velocity will keep on increasing, right? So similarly, the direction of gravity is this way. So as it keeps falling down, the velocity will keep on increasing, and here the velocity will keep on decreasing. From here to here, the velocity will keep on increasing, and if it moves this way, then the velocity will keep on decreasing. So the velocity will be maximum at this bottommost point. You can understand in terms of energy. There are only two energies. One is potential energy, another one is kinetic energy. Here is drop in height, so there is drop in potential energy. So that much there will be increase in the kinetic energy, and kinetic energy is half mv square. So v will increase. So the velocity will be maximum at the bottommost point. Option 2. Yeah. Okay.
Yes, sir.
This is a this you should have known. I don't know. This is okay. Two particles, mass and moving a circular particle. These are this is also a simple question. Got the answer? This is horizontal circle. So it's uniform circular motion. Because only in the case of uniform circulation, you can talk of time period.
The time period formula will be done.
See, time period is 2 pi by omega, right?
No, with based on the velocity and
No. Just get one formula. After that, you can find everything else. This is clear.
also
Okay. Now we just have to find omega. So when the thing is moving in a circular path, so if you draw the free body diagram, you can get the expression for omega. So free body diagram, what will be the forces?
it is centrifugal force and horizontally centrifugal and centrifugal. There won't be gravity.
Okay, this is not, the question is not clear. Suppose you assume it's moving under gravity. Okay, there is one, T square is proportional to R cube. You know this formula. What is this thing? The square of the period is proportional to the cube of the radius. What is this thing called?
In gravitational assembly, Kepler's law.
Yeah.
Radius, no, sorry, A cube means elliptical path to some. I don't know.
Yeah. It's valid for circular also. So
Okay.
here, if you use that, raised to the power 3 by 2, that's also not there. Their time period are no. Okay, he's saying time period is same. Oh, so this is not under gravity. Two particles.
Vertical circle.
Okay, so this is coming. Okay, we are doing. This is not Kepler's law will not come here. So you have to. He's saying that the time periods are same. So it's 2 pi r by the velocity of m. Should is okay. Straight away we got the answer. In the ratio of the angular velocity. So angular velocity is 1:1. The periods are same. No, period is the circumference divided by the velocity. 2 pi r by Vm and this 2 pi r by Vm. These two are equal. That means that Vm by r is same as Vm by r. Vm and V by r is omega. So omega of both the things are equal. So 2 is option 3. Is it clear?
Yes, sir.
So this is not under gravity. The first one is for gravitational things moving under gravity force. So this is not true here. Okay. Yes, particle moves from separate radius. Try this one. The particle moves along a circle of radius with constant or tangential acceleration. So tangential acceleration, this means d omega by dt is not 0. Omega is not constant. If the velocity of the particle is 80 meters per second at the end of second revolution after the motion has begun, then the tangential acceleration is okay. I think it's trivial. D omega by dt. So alpha is d omega by dt, right?
Yes, sir. So here omega is constant only, no, sir.
No. Alpha is constant. Omega will keep on increasing. Otherwise, there won't be tangential acceleration. No.
Tangential acceleration expression, no, sir.
This means that velocity at angular displacement theta equal to 4 pi is 80 meters per second. So alpha, right?
The tangential acceleration expression is r square omega only, no, sir. That's radial acceleration.
Okay, V from this. This will be one. So from this I can get omega at theta equal to 4 pi is how much? V by R, no? So et divided by 25 pi. That's 4 pi. So omega at I made a mistake. Okay, I'll come back to it. Is this clear? Distance covered is 2 pi r twice of them, so it's 80 meter, that's fine. V square equal to V square plus 2a, yes. So from this you get acceleration is 40 meter per and mutual acceleration. So V square, okay. So is this clear? Two revolutions.
Use current to force current. How do you get that?
No, this two revolutions, no. So it's twice 2 pi r, there is a distance. So along the circumference of the circle, you can write these equations of 1D motion and the acceleration is uniform because he has said constant tangential acceleration. So tangential acceleration is constant. So you can write the equations of motion for a 1D motion along the circular path. So v square equal to u square plus, and u is u square. U is 4. How is it coming? He has put initial velocity as 4. Okay, and
But
sorry.
8 is 0 there.
Yeah. I think this is 0. It's starting from rest, I think.
I didn't mention it, sir.
No, there is a mistake there. The particle is moving on a circle with constant information. The velocity of the particle is this much at the end of second order shape. Okay, so this is wrong actually. This thing is actually 0. Okay, so v square equal to u square plus 2as and u is 0 and v is 80. Okay, right?
So, why did they take that initial velocity as 0? They didn't mention that it starts from
A particle is along the circle with constant acceleration if the velocity of the particle. Okay, it is 0, but they have not mentioned it properly.
Okay, in the exam also they didn't mention me
See,
that
this is 2003.
okay.
Okay, so right now, so if there is a mistake in the exam, then someone will claim, so they'll give you the full mark if there is a mistake in the question. But nowadays, it's not that much problematic.
Okay.
But let me go to the latest questions. 2017. Okay, this one. This, I think it's also trivial. It's a theoretical question. One end of the string L is connected to a particular mass M, and other end is connected to a small peg. Horizontal table, so it's horizontal motion. Once it's a horizontal, it's a uniform circular motion. The particle moves in a circle with speed v. Net force in the particle. This is very, very trivial. Just wrote the free body diagram. So what is the answer?
P minus mv square by
Option 2, right?
m.
4.
Yeah. Mm.
It's option 2. 19 is 2. Okay. I think I made a mistake here. 19. I'm not given the solution. 10, 11 is there, and then 20. Nineteen is missing. Okay, well, let's leave it. According to me, the answer is this one, 2. Tension will be inwards, and mv square by r, that is mv square by l, should be outwards. So the net
Okay.
force is, actually they will be in balance. T minus mv. It's in balance. Okay, in some sense, no, this mv square by is not an actual force, it's a pseudo force. Okay, 4 is correct.
Okay, that will be balanced by the radial acceleration.
No, no, no.
Centripetal.
See, this is sort of a tricky question. It's a theoretical question only. Okay, this is an object, right? So the force acting on this is fixed. So the force acting on this object is a tension T. Okay, and there is a acceleration in this direction, which is AC, which is equal to V square by R, or here should be V square by L. Okay, so the net force in the radially inward direction is T, that is equal to mass into acceleration. So mv square is not actually a force, it's a sort of pseudo force. So the force is only T. Got it? Okay, so this mv square by L is actually acceleration term, not force term. So force is only T, and because of this force T, this body experiences a radially inward acceleration. So the force is only T. Okay, 18th. This is also trivial. So this is clear, no?
Yes, sir.
Okay. Particle starts with angular acceleration. So this is alpha. Okay. Theta is 100 at some particular time in a random time interval of t at t equal to 5 seconds. Yes. So you have to find Ti. Tf minus Ti is 5 seconds.
That is omega not only.
That is such an explanation. And for use 100 radians. Okay, starts no, so omega naught is 0.
Yes, sir.
So the time interval
So T2 minus T1 the whole square, no, so we have written like T square minus T1 square. But T2 minus 1 only 5 seconds.
so if you use the T2 minus T1 force here, so are you getting the answer?
No.
Delta theta is 100. That is equal to alpha is how much? So is it 100? No, where is the answer? Okay, whole square, no, so it is 10 then. 10 is also not there.
We could use like T2 minus T1 is equal to 5, T2 is equal to 5 plus T1, and then you could derive and quadratic equation, and that is left in the answer.
Okay. Okay.
I guess this expression itself is wrong, sir. That equation itself.
Okay, let's go to the 11th question. Okay, car of mass conditions.
These are the problems come in Newton's law of motion. Banking.
Okay, I'll just explain what I did here. See, theta equal to theta naught plus ud plus half a t square. No, that's omega naught t plus half a t square. And omega naught is 0 because the particle starts. Actually,
Yes,
this
sir.
is also not clear. Starts with the angular acceleration of 280%. If it moves 100 in a random interval, 5 seconds, 5 time turns. Starts. Okay, and see this one I can write for two dimensions. Theta 1 equal to this thing plus alpha t1 square. And similarly, theta 2 equal to this thing plus alpha t2 square. So delta theta is theta 2 minus theta 1. So these two terms will go away. So it will be just half alpha t2 square minus t1 square. It is not t1 minus t2, t2 minus t1 full square. Okay. And here, the second data is t2 minus t1 into t1 plus t2. And t2 minus t1 is 5 seconds because interval. And delta theta is 100. So half into t2 minus t1, that is 5 seconds. Half into alpha is 2 into 5 seconds into t1 plus t2. So this will give me t1 plus t2 as 20. So t1 is not known. If I assume t1 as 0, then t2 should be 20. That is not an option here. Okay, I'll come back to this later. Okay, so basically the car should not slip. So the friction force, which this particular inclination will give, that should be sufficient. That friction should be less than the maximum friction force. So frictionless road, okay. So the component of the weight that should balance centrifugal force. You understand this question?
No, sir.
See, the road is like this. Okay, so it's at an angle 45 degrees. Okay, and the car will be like this. This is car, which is say moving in this direction. Okay, the forces acting on the car. So basically, if it's a flat road, there will be a centrifugal force here, right? mv square by whatever the radius. Okay, so if the friction is there, then it will act inwards and balance this force. But instead of having friction, since the road is inclined, there will be a component of weight that will balance this one. So this is mg. So this component, there is mg either cos or sine. Okay, so that will balance this one. So you just have to equate these two. So it's 45 degrees now. So since it's 45, you don't have to bother whether it's sine or cos. So mg by root 2. So it is like mg into 1 by root 2. There is a component in this direction that should be equal to mv square by r. So m and m will cancel. So speed of the car. So you have to find v, right? So it is g by root 2 into r is 90. That is v square. Why is it given the mass and the speed of the car? So it is 90 minus 3 into 10 into 10, 10 divided by 2 raised to the power 1 by 4. So 30 by something. Y is tan theta. Oh yeah. This is actually sorry, 19 into root 2. Okay, this mv square by r. So what is that r? Is the radius of that this thing, right? So this is r.
Okay. Okay. Then that will be 90 cos 35 degrees.
What am I doing? This is mv square by r. So r is this one. Okay. All right. This mv square by the direction is wrong. This is not the direction of mv square by r. mv square by r, the direction is this way. Okay, so I have to take the component. So it's mv square by r. R is 90 degrees. mv square by r, so cos component.
Then sin theta also will vary nature.
Square by r. Right. So here it should be 1 by root. Got it?
Yes, sir.
So basically the root 2 should go.
But the sin theta, the value alone you tell me, sir.
See, mg is downwards, right? So the one along the plane will be mg by root 2.
But that mv square opposite to that one won't be mv sin theta.
mv square by r.
That is not along that plane, no. mv square by r.
So component along the plane is this angle. No, this angle is same as 45 degrees. So 1 by root 2 factor will be there.
Okay.
So v square will be root 2 will cancel. What happened suddenly? Okay, v square equal to r into g. R is 90, so 900, so it is 30. Right, this is correct only. G is 10, R is 90, so 900. Square root of 900 is 30. Okay.
So keep centrifugal force as it is, and then you take the G like
No, then you have to take normal reaction is there, no? Normal reaction is there. So to avoid the normal reaction, you have to take component along the plane. Okay, otherwise the normal reaction component will come.
no, I agree. What's up,
It's easy to resolve the forces parallel to the road and perpendicular to the road. Okay, normal reaction will be perpendicular to the road, so it will be in that direction only. If you take parallel to the road, the normal component will not come. If you take other direction, then the normal will, you have to take the component of the normal force also. Okay.
Okay.
So you try. There are other problems also, so you can try them. These are simple questions. This is uniform circular motion. Is it clear? Omega is constant. So which of the two is true? V in acceleration is perpendicular. This is true. Both, but this is not true. V is perpendicular to R. And acceleration directed towards the origin. V is perpendicular to R. That is true. And acceleration is towards the origin. This is also true. V is perpendicular, acceleration is directed away from the origin. So 3 is also true. No, both are perpendicular. No, both are perpendicular to each other. So option 3 is true. Is it clear? Yes. 17.
Can you explain it again, sir?
17 is uniform circular motion, right? R equal to cos omega t x cap plus sin omega t j y cap. So this is uniform circular motion because omega is constant.
Okay.
Okay. So for uniform circular motion, velocity and acceleration both are no. Velocity is perpendicular to R and acceleration is along R. So option 1 is not true. V in our parallel that's not true because V is tangential and acceleration is towards the radial. 3 V is perpendicular to R. This is true. And acceleration directs to the origin. So this is true. Option 3 is true. Option 4 is perpendicular to R and axis is away from the origin. This is also not true. So 3 is the correct option.
Yes, sir.
17.3. Okay. So try other questions also and let me know what you are not getting. So this link you are accessing, no?
Okay. Resend me.
I sent you something back. So here you can choose the topic. Okay. Which questions you want to solve. So circular motion, if you click, you'll get those questions. Okay, so try them. And if you're not getting, you let me know.
Fine.
Okay, shall we close now?
Yes, sir.
Okay, so tomorrow is class 12. So I can send you the playlist of electrostatic problems, similar to the one I sent for kinematics. So you can go through them.
Okay.
If the problem is simple, you can just skip.
shut down. Oh God.
What?
Sorry, sir. My phone must shut down, sir.
Okay, fine. So we'll close now. Bye.